Hey, what's going on, guys? Let's look at this problem right here. This question is asking the common source stage depicted in figure must be designed for a voltage gain of 20 and a power budget of 2 milliwatts, assuming W over L1 is equal to 20 over 0.18, lambda n is equal to 0.1 voltage minus 1, and lambda p is equal to 0.2 voltage power minus 1. Design the circuit. Okay. Here we know that R output is equivalent to RO1 parallel to RO2, and also we have to know that voltage gain AV is equal to GM times R out. Therefore 1 over, if R out is equal to RO1 parallel to RO2, we know that 1 over R out is going to be 1 over RO1 plus 1 over RO2. We can also write this one as R out is equal to 1 over RO1 plus 1 over RO2. Now let's go ahead and continue right here. Here RO1 is basically 1 over lambda n times ID, and then RO2 is basically 1 over lambda p times ID. Now here transconductance can be calculated using this formula. Transconductance for a MOS device is minus 2 ID divided by VGS minus V threshold. So also we have the lambda n and lambda p values are provided. Now what we are going to do is instead of this 1 over RO1, 1 over RO2, we are going to replace it with this values 1 over lambda n ID and 1 over lambda p ID. If we do that, R out will become, since this is already 1 over RO1, 1 over lambda p ID, it will come into numerator. So we will have 1 over lambda n times ID plus lambda p times ID. Okay, now let's go ahead and plug the values. But here our purpose is to find out the okay, here we want to find out the gain. Actually, gain is given. We have to design a circuit that will give a gain of 20. Okay, now gain is given. Let's go ahead and create the equation. Gain is equal to AV is equal to GM times R out. Then here we have equation for GM for a MOS of object and a MOSFET, and here we have R out equation we derived, because RO1 is equal to 1 over lambda n times ID, RO2 is equal to 1 over lambda p times ID, and we already created an equation for R out, that is 1 over RO1 plus 1 over RO2. So instead of this R out and GM, we are going to plug these values. So this is going to become minus 2 ID divided by VGS minus V threshold times R out is 1 over, I am taking the ID common, so we can see clearly cancelling, ID cancelling. So lambda n plus lambda d times ID. Here we can cancel this ID and this ID, and that gives us minus 2, and we have VGS minus V threshold. From this one we can calculate VGS, because V threshold is 0.4, that's a constant value, and we have AV, that is 20 minus 2. Let's plug all the values. VGS is what we are going to find. V threshold is 0.4, and here we have 1 over lambda n plus lambda p. Lambda n is, this is p, okay, lambda n is 0.1 plus lambda p is 0.2, and from this one if we solve for VGS, that gives us 0.73 voltage. Okay, now we have this one. Now we are going to solve for the drain current. ID is equal to half times W over L times mu n cox VGS minus V threshold square. VGS minus V threshold square. Now let's go ahead and plug all the values so we can calculate ID. Half W over L is provided, that's 20 over 18, 0.18. 20 over 0.18 and mu n cox. For a MOS object, that is 100 times 10 to the power of minus 6. Then VGS minus V threshold. VGS we just calculated, that's 0.73 and V threshold is 0.4 whole square, and that gives us 0.61 milliampere. Now we have found out ID. Now the next thing is we are going to find out the power. Power P is equal to VDD times I. I is basically, let's write the equation for I. I is equivalent to I ref plus ID. Okay, now here we can solve for I ref. Let's get rid of these things. Okay, let's plug all the values. Let's continue this one right here. Okay, power is 2 milliwatts, 2 times 10 to the power of minus 3, and then VDD is 1.8 voltage. 1.8 voltage times I ref plus ID, that is, we just calculated that one here, 0.61 milliampere. 0.61 times 10 to the power of minus 3, and from this one if we solve for I ref, that gives us 0.5 milliampere. Okay, now we have solved for I ref. Now finally we are going to derive an equation for ID2 over derive a value for ID2 over I ref. That's what we have to show to design the circuit. Now to do that, we have to know that ID2 is directly proportional to W over L2, and I ref is directly proportional to W over L ref. So ID2 over I ref is equivalent to W over L2 over W over L ref. Now let's go ahead and plug the value. ID2 we calculated to be 0.61 milliampere. 0.61 milliampere divided by I ref, we calculated that one 0.5 milliampere. 0.5 milliampere, and that one gives us 1.2. So finally we can say that therefore mref and m2 is equal to 1.2. That's a final derivation, final solution. This is our circuit. That's how we do this kind of problems. I hope you guys find this video helpful. Thanks for watching, and if you're trying to learn electronics too, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.